Hello everyone, I hope you're all having a great day. Today I'm here with a new science video for you guys. In this video, I'm going to be explaining the four fundamental forces of the universe. To start off, what exactly are the four fundamental forces? These are the forces that were together at the time of the Big Bang. These are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces govern the interactions of almost every particle in the known universe. Each of these forces has their own domain and have extreme variance in how long they are effective for. For example, gravity and electromagnetism have infinite range, whereas the strong nuclear force is only effective in the range of the diameter of a proton. These forces were all joined together at the time of the Big Bang, when the temperatures were 10 to the 31st degree Celsius and energies were in the range of 10 to the 19th power gigaelectron volts. All physics derives from the interactions between the four fundamental forces, and most of these forces have certain carrier particles that carry them. To start off, we have gravity. Gravity is the outlier of the four fundamental forces. It was the first force to separate from the rest of the forces in the Big Bang. This force is also not joining together with the other three forces to make a grand unified theory. It's by far the weakest of the four forces. In fact, the magnitude of the electromagnetic force is 10 to the 36th power times stronger than gravity. Gravity is the biggest player over long distances, however, as it has infinite range. Gravity makes it so every other particle in the universe affects every other particle in the universe. Therefore, a particle in your body is affecting a particle at Alpha Centauri. However, due to how gravity works, the interaction between those particles is so weak it may as well not even exist. Gravity is only an attractive force and never repels, which is why the universe expanding at accelerating pace confounds physicists. This is the electromagnetic force. Every particle in the universe has one of three charges. It has either a positive charge, a negative charge, or a zero charge. An example of this is a proton having a positive charge, an electron having a negative charge, and a neutron having a neutral charge. There are also other types of charges, but such as color charges, which quarks are. They have three colors. When combined, they make a neutral color, but that's a different thing. The electromagnetic force is an all-permeating force. It governs the interactions of both moving and stationary particles that have an electric charge. All of biochemistry is caused by the electromagnetic force because it governs all chemical processes. However, it's not the dominating force. You may wonder, if it's also all permeating, infinite range, and is so much stronger than gravity, why doesn't it dominate the entire universe? This is because large objects on a cosmic scale tend to be electrically neutral. If this was not true, then they would all attract or repel each other, and electromagnetism would rule the universe. The electromagnetic force is also responsible for pushing the protons in an atom apart, but it's overcome by the strong nuclear force which holds an atom together. Now, you may think, in an atomic nucleus, there are protons that are bunched up very tightly. Now, due to the electromagnetic force, they will want to push apart because they are the same electric charge. There is a force of approximately 20 pounds affecting them at any given time. And this is only if you take two protons. In a uranium atom, it's closer to 70 pounds. Now, you may think, well, that's not a lot, but then you have to consider the size and scale of a proton. And that's why atomic bombs are so powerful, because whenever this energy is released, it explodes in a spectacular explosion. All matter has an electric charge, which is either positive, negative, or neutral. Next, the strong nuclear force. This is the force responsible for holding an atom together, and more specifically, holding the protons in an atomic nucleus together. It's a contact force, which means it only works at very small distances. In this case, the distance that it works at is the diameter of a proton. This is the strongest of the four fundamental forces, being 100 times stronger than the opposing electromagnetic force. This is important because if it was around equal in power, just slightly greater than the electromagnetic force, it would be very easy to knock protons out of an atomic nucleus. However, this is not the case whatsoever. Now, the weak nuclear force. To be honest, this is the one I don't understand completely, but this is the one that governs the decay of atoms. It's the only force that knows whether the particles it's affecting are matter or antimatter, and it's the only force that knows the spin of the particles it's affecting. It's also the sole force that can change the flavors of a quark. Now, flavors is just a way to classify them. It governs the decay of certain particle and can detect the left or right-handedness of particles, which is a scientific term for spin. It helps initiate the nuclear fusion that goes on in the sun, as it helps with the particle decay. It has an extremely tiny range, even smaller than the strong force, and it's carried by W and Z bosons, which are massive particles that interact very heavily with the Higgs field and so have a lot of mass. This is a topic for another video. So I hope you guys enjoyed this presentation. If you did, please remember to like, share, and subscribe to my channel. If you wish to learn about any of these forces in greater detail, comment down below and I will make a detailed video explaining it. Thank you. See you next time. Bye.